Recorded is rolling. It is Monday, March 16th. So we're going into the week leading into spring break. Spring break's at the end of this week. Still on module 10. So we're going to do 10.3 and 10.4 this week. 10.3 is permutations and combinations. I'll show you guys some examples there. We'll do 10.4 tomorrow. Lesson 10.3 and 10.4 is open on Alex, so that'll be this Friday. I'll give you guys Wednesday and Thursday as Alex days. And since we're in a probability module on Friday, I'll do a game theory lesson with you guys, game theory activity. All right, so for permutations and combinations, I think a really good example here, a couple of examples. Right, one for each one of these has to do with cards. Right, so I recorded a longer video. I think it's about a half hour, 40 minutes somewhere there. It has a bunch more examples, but I'll just do a few fundamental examples with you guys, and I think that'll pretty much cover what you need. Right, so most of what you need is right on this page, and I'll do some examples with the cards. So the permutation to looking for like how many ways can something happen if a specific order matters. Okay? And then if you take the reciprocals, like what's the chance of that happening? Like I could say, what's the chance of I draw 4 cards out of the deck and there are these 4 aces in this order. Okay. Now, by the time we get to combinations, it's a similar idea, but you don't care about the order so much. Right. So, like how, like if I draw 4 cards randomly out of the deck, let's say like these 4 right here. Okay. How many different cards could they possibly be? Okay. Like, what's the chance that it's those 4 cards right there? But I don't necessarily care about the order, right? Or if I was to say the question like, what's the chance that they were the 4 aces? Then that would be a combinations question. Again, I don't care about like, oh, the spades have to be first or something like that. Okay. Right, so now there's formulas that go with these, but I want to build into it and show you guys how to think about this. Right? Right, so like where does this come from? Right? And I think it's something that you guys kind of seen before. So here, what if I just do the first 4 cards? Right. So what's the chance that this pattern happens exactly? So the first card would have to be the ace of spades. You guys see that? Hey guys, you guys tell me. What's the chance that the top card is the ace of spades? 1 out of 52. So let's say probability. Probability. Okay. And then playing off the scenario right here. Okay. Equals. Okay. Yeah, you guys said that the first card being ace of spades would be 1 out of 52. So as they turn it over, oh, hey, it happens to be ace of spades. Well, that was going to happen 1 out of 52 times. I make believe I didn't break the step. Right. Right. So now that one's locked in place. Right. And now we can move on and say, okay, well, again, for this pattern to happen, now we can move on to phase 2. Right. What's the chance that this next card is the ace of diamonds? 1 in 51. Because now there's only 51 cards in the deck because we removed 1. Okay, and there's only 1 ace of diamonds. Right, so there. Right, now that that's locked in place, we're going on down the lines. But you guys can figure out the rest of the fact. What's the chance next card's the ace of clubs?
1 in 50.
Yeah, 1 in 50. So boom. And then how about ace of hearts?
1 in 49.
Yeah, 1 in 49, which is 49 cards left, only 1 of them is the ace of hearts. Right? Right, so what's the chance, assuming that he's shuffled this up and this really had been random, what's the chance that that specifically happened in that particular order? Well, we can multiply this out here, and calculator here. Right, so I'm going to multiply the denominators, so it makes this a fraction. Right, so 52, 51, 50, 49. Right? So the chance of that happening, the probability is 1 out of 6 million. 497,400. So very small probability. Right. Now, how can you formalize this? Right. Well, there's this formula that goes like this. It has these exclamation signs. Guys, what's the exclamation name? You might possibly remember this from last semester. Does anybody remember? It means factorial. So this means factorial. Right. It means you multiply all the numbers down, like all the whole numbers down to 1, right? So, in this case, I'll do NPR is the representation for this. Okay? I'm saying it's n factorial over n minus r, and then that being factorial. So in this case, if I have 52 cards and I'm choosing 4 and I want them to be in a specific order, it'd be like 52 cards, and then permutations, that's what the P stands for, and I'm choosing 4 cards. So how many ways could this possibly happen? So 52 factorial divided by, and then I'm choosing 4, so I'll do 52 minus 4, and then that factorial. Okay. Guys, 52 factorial, that is 52 times 51 times 50 times 49 times 48, and it just goes on down. So I'll just do factorial and put it out there. You guys see that? Okay. Hey guys, what is 52 minus 4? That is 48. Okay. And then that's also factorial. So it's times 47, 46, 45, all the way down. So I'll just call that factorial. You guys see what's going to simplify here? You guys see that? Okay. That cancels. And what I'm left with is this, which turns out to be 6,497,400, because I just multiplied that a minute ago. Which looks like this number, doesn't it? Okay. So what that means, guys, the way you interpret this is that, oh yeah, go ahead.
Do it for the top factorial, you keep going down until it equals the bottom factorial.
Yeah, you do. Guys, 48 factorial is 48 times 47 times 46 and so on. And this is also 48, 47, 46 and so on. So all these numbers are going to cancel out. It's a whole string of numbers. Okay? Yeah, they all cancel out.
So like if the bottom factorial was like 45, you would keep going.
Yeah. Okay, yeah. If this was 45 factorial, then it would only cancel out with the 45 factorial up here, and you'd still have the 48, the 47, the 46. Yeah. Okay. So what this means is that if you draw 4 random cards in a particular order, there's about 6.5 million different ways for that to happen. So the chance of any one particular outcome, like 4 aces in a specific order, would be one out of that. Okay. All right, you guys see that? Now, let's go on to combinations. So this is where maybe the order doesn't matter. What if I just care about drawing the 4 aces, but the spades doesn't have to be first. It could be in any order. So, okay. Well, guys, let's do combinations then. So the probability of drawing the first 4 cards are aces. Right. Well, what's the chance that the first card I draw is one of the aces? What do you think? Well, it's not 1 in 52. It's what? It'd be 4 in 52, wouldn't it? Guys, there's a 4 out of 52 chance that the first card is just one of the aces, wouldn't it be? Okay. It doesn't have to be the spades. It could be in any of the aces. Okay. But now that I've drawn an ace, what's the chance the next card is also an ace?
3 in 52.
3 out of what? 51. Ah. And then what's the next?
2 in 50.
Yeah, now there's only 2 aces left, and there's only 50 cards in the deck. Right. And then, okay, now there really is 1 ace left out of 49 cards. Okay. So this would be a combination. This is called combinations. Right. Where again the order doesn't matter. Okay. So they could be in any order. Right. Well, what does this look like? Well, I think it's the same denominator as had before, the 6.5 million number. So I'll copy that down. 6 million. 497,000. Yeah, 400. Okay. But guys, what does the numerator come out to? That's 24, isn't it? 24. Right. So let me divide this out here. What's over 24? Okay. So this reduces to 1 out of 270,000. Okay. 725. Okay. Which is much more likely. Does that make more sense? It'd be much more likely to happen if you don't care about the order. That makes sense, right? Okay. It'd make more sense. Okay. Now, there's a formula that goes with combinations, and I have it right here. It looks a little different. Okay. So NCR would be, you do n factorial over n minus r factorial, right? But then r factorial, right? So in this case, if I'm doing 52 cards and I'm choosing, so C for combinations, or say choose 4, that'd be 52 factorial over, well, 52 minus 4 would be 48 factorial. We saw it before. And then 4 factorial because I'm choosing 4 cards. Except, okay. So that's 52 times 51 times 50 times 49 times 48 and so on all the way down. And then 48 factorial is, well, it's going to cancel out with this. But then I have times 4 times 3 times 2 times 1. Okay. And look at that. Isn't that just upside down of what I have up here anyway? So this has to come out to 270,725. What that means is that if you choose 4 cards randomly, again, you don't care about the order, there are 270,000 some different combinations of 4 cards that you could possibly choose. And then you've exhausted all the options in the deck. Okay? You can say, what about the 3 of spades and the 4 of hearts and the 5 diamonds and the jack of clubs or something, right? That could be one combination. Again, you don't care about the order. Okay? That's one of these 270,000. Okay. Okay. You guys go with permutations and combinations?
Yeah.
Finally, I think I showed you guys this last semester, but the calculator will do all this. So let me show you guys this too. Let's go back to permutations. So guys, check press your calculator. Type 52, as in 52 cards in deck. Then go to this button that says PRB. You see PRB? And then there's permutations, there's combinations, and there's factorial. Let's start with permutations. Permutations. We'll go back to this one. And I'm going to choose 4 cards. Right. And yes, caring specifically about the order, there should be about 6.5 million different permutations of 4 cards I can choose. Let's see if it does that. Yeah, look at that. The calculator did all that for me. And then this is what it's doing behind the scenes. You guys get that? Get that? Calculator did it all. Right? Or let's start over, clear that out. Let's do 52. Let's do combinations. To go back to this button that says PRB for probability. Let's slide over to combinations. Let's do combinations and then 4 cards. Okay. Now combinations should be 270,000. 725. See if it is. It is. It's exactly. And of course, this is what it's doing behind the scenes. Right, you guys get all that? Right, guys good?
Well, I think it's a lot of it. It's a syntax.
Let me see. Do what you got. Okay, well you have to type a number. Yeah, there you go. Well, okay. Type. That's hold on. Right, you got 52 cards. You're gonna choose 4.
Oh, okay, I get it.
All right. All right, guys, good. Now, guys, almost all these questions in this section are kind of like that. They're either permutations or combinations. Okay. Now, what's going to there are a few that are a little off the beaten path. Yeah, I covered more examples in the longer video if you want to see some more examples. Okay. I'll do one more with you guys here. Let's do phone numbers. It says, what's the probability that a 7-digit phone number generated using the numbers 2, 3, 2, 5, 2, 7, and 3? Okay. Comes out to specifically this number 222 3357. So it puts them all in numerical order. What's the chance that we see that? Okay. And the trick to this is that some of those digits are repeated. Like there's multiple 3, or sorry, there's multiple 2s. There's a couple of 3s, but there's only 1 5 and there's only 1 7. Okay. So what's the chance that you take these 7 numbers and it comes out to this order 2 2 2 3 3 5 7, like exactly that order. Exactly that order. And the way I would approach there might be a couple different ways you could approach this, but the way I would do is to get the answer is I say, well, the chance that this first 2 is a 2, okay, would this be, guys, see there are 3 2s out of 7 digits? So isn't there a 3 out of 7 chance that the first number is going to be a 2? Right? Right. And if you have that locked in place, chance the next number is a 2. Well, now there's only 2 2s left out of 6 remaining digits. The next number being a 2. So now there's only 1 2 left out of 5 remaining digits. Is that okay? And then how about this 3? Well, there are 2 3s, so there are 2 ways for there to be a 3 there out of the 4 remaining digits. Once you have that in place, there's only 1 3 remaining out of 3. Okay. And then these last 2 digits, well, there's only 1 5, so that's 1 out of 2. Okay. And if you get down there, guys, if you get this 5 locked in place, there's a 1 in 2 chance. There's only 1 number remaining. So there's only 1 way to write the last number. So the last number's got to be a 7 if everything else is locked in place. Except, and so see how this cleans up here. 3 times 2 is 6 times 2 is 12. Out of, hey, is this 7 factorial right here? Is that factorial?
Yeah.
What is 7 factorial? Here, I'm going to use that factorial. You guys know 7 factorial is 7, 6, 5, 4, 3, 2, 1. That's what it is right here. Okay. I'm going to try a factorial and see what it tells me. So this is 12 out of 5,040. Okay. If I do 5040 on 12, that cleans up to, there's a 1 out of 420 chance. Yeah, that was the book answer right there. Okay. So if you take these some digits, scatter them around, if you pull them out of a hat, what's the chance they land exactly in that order? I have a 1 out of 420 times. Yeah.
Didn't that just 3 factorial and 2 factorial times 1 to
NC Texas A&M.
Yeah. You can do that too. That's what it looks like. Yeah. So there's 3 factorial, there's 2 factorial, and then 1 factorial, 1 factorial. So you can do that. 3 factorial, 2 factorial, 1 factorial, 1 factorial over 7 factorial. Looks like that'll get you there too. Yes. All right. So do you guys want to watch more examples on the upload video? You can do that. If you want to jump into your Alex 10.3, 10.4, you do that, and we'll do 10.4 examples tomorrow.